In this tutorial, we are going to continue with the same objective, that is to find the formula of the gradient of the function f of x equal to x cubed at any point. In the previous tutorial, we read in 7.2 page 117, you can find the formula for the gradient of the function f of x equal to x squared and other functions of the form f of x equal x power n. Again, you need to consider the gradient of a chord joining two points which are close together on the same curve and determine what happens when the point become very close together. Then, as we said before, we need two close points to be able to work out the gradient. This time the point B has the coordinates x and f of x instead of writing y. Then the point C that is close is going to be x plus h and f of x plus h. Therefore, the formula is going to be as follow: the limit for as h tends to 0 for f of x plus h minus f of x divided by h. This is the formula that we are going to use now to solve example 3, page 118. We are asked to find from the definition of the derived function an expression for f prime of x when f of x equal to x cubed. Let's remember, f prime of x is the tangent or the gradient when f of x equal to x cubed. Let's work out this example together. We have f of x equal to x cubed. Then f prime of x from the definition, it's the limit as h tends to 0 for f of x plus h minus f of x divided by h. We know the limit as h tends to 0. At the end of solving, we are going to substitute h0. First, f of x is equal to x cubed. Then f of x plus h, we have to substitute x plus h instead of x. Then we are going to get x plus h cubed. Let's now substitute both in the formula or in the definition. It's the limit as h tends to 0, f of x plus h is x plus h cubed minus f of x, that is x cubed, all divided by h. Let's expand x plus h all cubed. Then it's equal to x plus h multiplied by x plus h squared. We already did in previous exercises that expanding for x plus h squared, that is equal to x squared plus 2xh plus h squared. Now let's expand. Let's split the first bracket. Then x multiplied by x squared is x cubed plus x multiplied by 2xh is 2x squared h. X multiplied by h squared is xh squared. Now h multiplied by x squared is plus h, or x squared h, plus h multiplied by plus 2xh is 2xh squared plus h multiplied by h squared is h cubed. Let's substitute this now in the definition, or first we can collect the same terms. Then we have x cubed plus 3x squared h plus xh squared and 2xh squared is 3x squared h. Then the remaining is going to be 3xh squared plus h cubed. It have no similar term. Let's substitute now in the definition. Then the limit as h tends to 0 is equal, instead of x plus h cubed, we are going to substitute x cubed plus h x squared h plus 3xh squared plus h cubed minus x cubed. This is divided by h. Now again, let's collect the same terms, the similar terms. Then we are going to get x cubed minus x cubed cancel each other, 3x squared h plus 3xh squared plus h cubed are the remaining. all divided by h. Now we can say that h in the numerator is common in all the terms, so we can take it outside. Then the remaining will be 3x squared for the first term, the second term 3xh, and the third term h squared. This is divided by h. H in the numerator can cancel h in the denominator, so the remaining is going to be limit as h tends to 0 for 3x squared plus 3xh plus h squared. Now, after all of the simplification is done, we can think about substituting h. We are saying limit as h tends to 0. Then if h is almost 0 or very close to 0 or almost neglected, then everything multiplied by h is to be neglected as well, because it will be very small number. Then the remaining will be 3x squared. Therefore, all of the process that we did is only to find the derived form for f of x equal to x cubed. So using that definition, we were able to do many steps to find the derived form f prime of x when f of x equal to x squared. And this is what they did in the example. By the end of substitution, they substituted h equal to 0, so we found 3x squared equal to f prime of x.